Good morning. Good morning, everyone in the room and everyone joining us online. This is Training School 2, Smartings Training School 2. And we are at the University of Cambridge here, Department of Engineering. I'm Professor Abir Al-Tabbbaa, Professor here of Civil and Environmental Engineering, and we're hosting this training school. So the theme of the training school is Repair Technologies and Smart Solutions. We have the 15 Smartings ESR in the room, and we have a number of you joining us online. So welcome to you all. And if you have joined us in Training School 1, which was online hosted by TU Delft, welcome again. We're delighted to have you here. The host of Smartings is University of Ghent. Okay, so what I'm going to do is just briefly take you through Smartings for those of you who are new. Okay, so Smartings is an H2020 ITN. And it was in the 2019 round. Smartings stands for Self-Healing, Multifunctional, Advanced Repair Technologies and Cementitious Systems. And we started in December 2019. It's a 4-year program. We have 15 ESRs, and the budget was over 4 million euros. We're a group of academic institutions and industry partners, and we are covering the whole remit of basically self-healing agents, developing materials and processes and modeling, all the way to concrete technology, structural design, and durability and sustainability aspects. And then we are working again across the other dimension, research and development, innovation, and markets. Our website is smartings.eu if you'd like to visit us there and see a lot more information on the website. So what are the objectives of Smartings? So the idea is, generally of these ITNs, is to provide broad academic, multidisciplinary, intersectoral and transferable skills training to the ESRs, and train, in our case, 15 linked PhD researchers through research on self-healing repair technologies. Specifically for us, we are focusing on specific technical topics of self-healing, cementitious materials, and advanced local repair and self-repair systems, science-based modeling of self-healing systems, assessments and prediction of durability, service life and sustainability, entrepreneurial skills, and technology-tailored approaches for commercialization of new materials and dissemination of research results. Smartings consist of a number of work packages. So work package 1 is improving self-healing concrete. Work package 2, advanced local repair and self-repair. Work package 3 is durability, service life and sustainability. Work package 4 is technology transfer and entrepreneurship. Work package 5 is all the training activities. Work package 6, outreach and dissemination. And work package 7, management of the network. So schematically, here is a diagram of all the different research projects that the 15 ESRs are doing. So we have on the work package 1, the improved self-healing concrete in terms of vascular systems, capsules, bacteria, mixed design, and then modeling. Work package 2, advanced local self-repair. There is self-healing grout, self-healing repair mortar, self-healing cover system, self-sensing, and then we go on to work package 3, durability, service life, and sustainability. So we have cyclic and impact loading. Then we have real extreme conditions. Work package 12 is chloride-induced corrosion. Then ESR 13 is service life design, ESR 14, life cycle analysis, and then work package 4, technology transfer and entrepreneurship. We have ESR 15 on business models. Okay, so that's a brief overview of smarting. So I wanted to introduce another project to you, and this is UK-based. It's RM4L. This is Resilient Materials for Life. It's an EPSRC UK government-funded program grant, and it's around £5 million. And we started in 2017, and it's now a 6-year program. So it's sort of been running in parallel with smartings, and it's very much doing the same, well, complementary research work. Our website is rm4l.com. This is a collaboration between Cardiff University, Bath University, Bradford, and Cambridge University. Similarly, we have sort of a long-term vision and a shorter-term vision. So our 2050 vision is for a sustainable and resilient infrastructure containing smart materials and structures that self-regulate, adapt, and repair with our external intervention. And then the shorter term vision, sort of towards the end of RM4L, is to deliver a transformation in self-healing of construction materials through a biomimetic approach in which the material self-controls its own diagnosis and healing, and the evolution of the next generation healing systems that cover diverse and complex damage and deterioration scenarios. So schematically, we've done that into self-diagnosis and self-healing of cracks, chemical attack, aging, and cyclic damage. Again, in a similar fashion, we have different research themes. The research theme 1 is self-healing of cracks at multiple scales. Research theme 2 is self-healing of time-dependent and cyclic loading damage. Research theme 3 is self-diagnosis and immunization against physical damage. And research theme 4 is self-diagnosis and healing of chemical damage. And then we've grouped the different aspects. So we've got the self-healing technologies, encapsulations, microbial, vascular, fiber and tendons, and these systems integrated together. And then on the other side, we have the various self-diagnosing technologies, optical, can't see without my glasses, sorry, optical, piezoelectric, electrochemical, not these glasses, these are reading glasses, electrochemical and chromogenetic, and then we're doing modeling and tailoring technologies. This is THMC models, optimization, design models, and sustainability, and then scaling up technologies, large scale lab testing, field trials, costing, and sustainability. And then we have vertically down the different applications that we've been working on. So, cast in situ, precast, repair systems, overlays, and geotechnical systems. I think that pretty much covers the slides. And similarly, we have quite a number of industry partners working with us. And of course, we're collaborating, developing technologies together and realizing our vision through applications, as well as industrial take-up through the supply chain, and basically relying on our industry partners to work with us on real, so full-scale live demonstration projects. Okay, I must obviously thank all the researchers who have helped me a great deal with organizing this event. So we have the RM4L postdoctoral research associates, and basically the wider Smartings TS2 organizing team, from my researchers. So thank you to all of you, Heba, Livia, Shupriya, Vahid, Christos, Jamie, Benny, and Rami. Before I move on to the details of the training school, a little bit of publicity. So we are just about, well, we've just embarked on a new large research initiative called Digital Roads of the Future. These are two big grants. One is European Commission and one is EPSRC, all basically around roads and future roads. And the idea is to combine the physical product with the digital process, and combining smart materials with digital twins, with data science, and with robotics and automation. I am leading the smart materials corner, and we're focusing on digitization, decarbonization, and the environment in developing smart pavement materials. We have a number of vacancies at the moment, so if anybody here or online is interested, we have principal research associates, we have a number of senior research associates, and we have a program director positions advertised on our website. Okay, and moving on to a brief description of the 5-day training school. So today we're starting with 3 talks to start with from our Smartings members, and I'd like to thank the 3 of you in advance. Daniel, Mercedes, and Liberato. So I'll come back to the introduction later, but this morning's session is about infrastructure repair, so providing you with an overview and then covering the challenges, the materials, and the technologies. And then my colleague, Gopal Madabushi, is going to come and talk to you about the large-scale geotechnical centrifuge facility that we have. For our online attendees, I have drawn a line between what's available online and what, I apologize, is not available to you online. So we're going to have a visit to the Schofield Centre this afternoon. Tomorrow, it's very much about smart solutions and focusing on encapsulation. So we've got, in the morning, again, presentations from Smartings and the Cambridge team on different encapsulation techniques. And then after lunch, we have an afternoon lab demonstrations and tours. Friday, day 3, is RM4L plus intellectual property and intercultural communication skills. So only the first lecture in the morning is available to our online attendees, and then we have a workshop with the RM4L PDRAs and 2 sessions in the afternoon on intercultural communication skills and intellectual property. And then Monday, we're grateful to colleagues from National Highways. There's about 5 or 6 of them who are joining us online or in person, presenting industry perspective, so giving us an overview on National Highways, talking about their concrete legacy program, pavement repairs, and giving us examples of case studies, and then looking at the future and digitization. And then again, for our those attending in person, we have a poster session with feedback on your posters. And finally, Tuesday, this is all, I'm afraid, for those attending in person. So it's team communication skills, and then in the afternoon, Pachikucha presentation, and then an award ceremony at the end. So I'd like to start the morning session with 3 presentations, first from our Smartings partners. And I'd like to invite Daniel from Penetron to start talking, giving us your talk on Penetron admits for the white tank system to waterproof concrete structures, from projects to realization and case studies. Thank you very much, and welcome again, Daniel.